Lesson 1.3, sets of numbers. So our objective for this lesson is to classify numbers as belonging to the set of natural numbers, whole numbers, integers, rational numbers, or real numbers. And we're going to start by defining these 5 sets of numbers. All right, so these first 3 sets can be defined by simply showing what numbers are in each set using set notation. So starting with the natural numbers are also known as the counting numbers. They're the first numbers that you learn when you start learning math, you start learning to count things. And so this set starts with 1, and then 2, 3, 4, and goes on to infinity. So those are the natural numbers. The whole numbers are just the natural numbers plus 0. So we're going to include 0 in this set. Otherwise, it's the same as the natural numbers. So 1, 2, 3, 4, etc. All right, and now the integers are the same as the whole numbers, except now we can have negative numbers as well. So the integers, we're going to start with a little dot, dot, dot to indicate we started back here at negative infinity, and we've gone up, and we'll put maybe -3, -2, -1, then goes to 0, 1, 2, 3, dot, dot, dot. And that's how we're going to show the integers in set notation. To define the last 2 sets, we're going to need to use words, because for rational numbers and real numbers, we're not going to be able to list out the numbers in those sets the way that we did for natural numbers, whole numbers, and integers. The rational numbers are the set of all numbers that can be expressed as a fraction. So rational numbers include natural numbers and whole numbers and integers, but they also include all of the fractions in between those numbers, like 1/2, 2/5, 417 53rds. Anything that you could write as one whole number over another as a fraction is going to be a rational number. Next, the real numbers are the set of all numbers that can be shown on a number line. So this is every number that you can put on a number line. So that's going to include all the natural numbers, all the whole numbers, all the integers, all the rational numbers, but it's also going to fill in any gaps between any of those. And so it's going to include numbers like the square root of 2 or pi that you can't write as a fraction, because as a decimal they would just go on forever with and never repeat. So those are called the irrational numbers, and the real numbers include those irrational numbers as well as all of the other numbers that we've talked about. To show the relationship between these 5 sets of numbers, let's draw a Venn diagram. So the smallest set that we've talked about is the set of natural numbers. So let's draw a circle representing the natural numbers. And now remember, the whole numbers included all the natural numbers plus 0. So we're going to draw a little bit bigger circle that completely includes the natural numbers, and these are going to be the whole numbers. And so remember, the only number we've added to go from the natural numbers to the whole numbers is 0. But still, the natural numbers is a subset of the whole numbers. And then next we have the integers, and the natural numbers and the whole numbers are subsets of the integers. So we can draw that like that. So we've now added to the whole numbers, we've added all of the negative natural numbers. And so we've actually added an infinite number of new numbers to get to this new set. And next we have the rational numbers. And again, the natural numbers, the whole numbers, and the integers are all subsets of the rational numbers. And if you think about that, any natural number that you can think of, you can also write as a fraction just by putting 1 under it. So for example, if you've got a natural number here, let's say 42, if you just put 42 over 1, now it's a fraction. And so all of these are going to be included in the rational numbers. All right, and then finally, let's draw one more set here, and these are going to be the real numbers. And now we mentioned that going from the natural numbers to the whole numbers, we really just added one number, 0. But then going from the whole numbers to the integers, we added an infinite number of new numbers because all the negative numbers are now included. Going from the integers to the rational numbers, not only did we add an infinite number of new numbers, but there's an infinite number of rational numbers between any two integers. And the same thing is true for real numbers. When we go up to real numbers, there's an infinite number of irrational numbers between any two rational numbers that we can think of. So we're really increasing the number of members of each of these sets. But we draw this to show you that each of these is a subset of the real numbers. And now, the last thing is what goes outside of here, what goes in this region up here, and that's going to be the imaginary numbers. And so those numbers are those that aren't anywhere on the real number line, and those are going to be like the square root of -1. We call that I. It's an imaginary number, and those numbers are important, but they're not numbers that we're going to talk about in this class. In this class, we're going to focus primarily on the real numbers. All right, finally, let's do a few examples. We're going to choose the first set, or the smallest set, that includes each of these numbers down here. So starting with 42, well, 42 is positive, and it's a counting number, so that's going to be right here in the natural numbers. We'll put that 42. -1. So remember, the natural numbers and the whole number. Natural numbers only include positive numbers. The whole numbers only include positive numbers plus 0. So the smallest set that's going to include -1 is going to be the integers. So that's going to be -1 right there in the set of integers. Next, square root of 7. So for square roots, if you have a number that is not a perfect square, so a perfect square would be something that is the square of a whole number. So 1 square root of 2 is 4, then 9, 16, 25. The numbers that are the square of a whole number, the perfect squares, the square root of those numbers are going to be obviously rational numbers. But any other number, if you try to take the square root, it's going to give you an irrational number. And so the square root of 7 is going to be up here in the real numbers. So the square root of 7 goes up there. All right, 0. Remember, 0 is the one number that we added to the natural numbers to get the whole numbers. So 0 goes here in the whole numbers. 4/5, that's a fraction, so it can't fit in any of these first 3 sets, but it fits nicely here in the rational numbers. So this is the 4/5 is going to go right there. And finally, the square root of 16. So here we have another square root, but 16 is a perfect square. The square root of 16 is just the number 4. And so that actually goes right here in the natural numbers, the square root of 16. Just another way of writing 4. All right, so hopefully that'll get you started on your homework for this evening. Good luck, and as always, please, if you have any questions, don't hesitate to reach out to me.